All righty, we're on. Any thoughts about anything? All right, so last class we were doing this game uh, in which we have three players. The oracle assures you that things are that either the axioms or things that you've assumed by deduction are true, right? So if you assume something by an axiom or by deduction, then the oracle assures you of it. While the prover's goal is to prove the statement, and the adversary's goal is to prove that it's not true. All right. Why it's so loud? All right. So suppose you're an oracle and you're trying to assure somebody that for all x something is true, then what are other people going to do? Other people, like the adversary or the prover, are going to say, oh, you're saying it's true for all x, so I'll give you my favorite x, and you assure me it's true for that x. And if the oracle is assuring you that there exists some object with a given property, then you can say, all right, give it to me, right? Now, since we don't actually have the oracle during the test, what you do is you write down, if we're saying there exists an x with a property, then we're saying we're giving it a name. We're saying let x sub, maybe sub exists as a subscript, be the object that has that property, right? And what about the prover? If you're proving that something exists, then there are non-constructive ways to prove it, but we're not doing that in this course. We're doing constructive proofs. So the way you prove that something exists is you construct it, right? So that's where the prover comes up with it if they're proving the exists, right? But if you're trying to prove a Forall statement, and if you're trying to prove a Forall statement, then hello, are you still working? Yeah. Right, I pushed the button. Maybe it'll help. Hello. All right. If you're trying to prove a Forall statement in 1019, you would have probably said, let x be arbitrary, right? People remember that? And then you prove it for an arbitrary x. Now, I think people have a confusion between let x be a random thing where you have a distribution and let x be something that my oracle gives me that I like versus something that's worst case, right? So just to emphasize the worst case nature of it, we're going to say, let say x sub for all be an arbitrary object given to me by an adversary who's trying to beat me, right? Does that make sense? And that's the entire game. All right. So we're going to have, as I say, we have three players. The prover who wants to prove it provides the exist statements. The adversary who wants to disprove it provides the for all statements. Right. And when we're saying that the statement is valid, we want it to be true in every model, right? So that's kind of like a big Forall on the outside. And so we can think about the adversary providing the model, right? And the oracle assures you of things that you've assumed. All right? All right, so the prover asks help from the oracle and makes conclusions. All right, so here we're just doing a really, it's supposed to just demonstrate the ideas. And in terms of all right, so we want to prove that this is true or not, right? And of course, it depends, whether it's true or not depends on the universe, right? Here, the universe depends on, well, who are your boys and girls and who loves who, right? So is this statement true in every universe, right? Clearly not, right? It depends. So, so in some questions, I'm going to provide the universe, like I might draw this picture, and or I might say we're doing it over the integers or the reals, and sometimes we want to prove it over an adversarial universe, right? And then what does the game do? It reads the statement left to right, right? So if the oracle is trying to assure us of this, then the prover can give some boy, right? She's saying it's true for all x. Any advice on how to fix this mic problem? All right, she's trying to assure us for all boys. So you can say, hey, how about Sam, right? And so then she has to assure the statement for Sam, right? And then she's saying some girl exists, so she provides the girl, right? And then she assures you that Sam loves Beth, right? And if we're trying to, now, if I'm trying to prove the same statement, well, I have to sort of try to be the oracle, right? So the adversary gives me an arbitrary boy, right? But since we don't have the adversary actually in the room with us, we have to say, let B be an arbitrary boy, right? And then I have to prove there exists a girl. And how do I do that, right? We have to, right? We have to say, well, in this case, right? We could do an exhaustive search, right? We can say Sam loves Beth and Bob loves Marilyn Monroe and so forth, right? Everybody good? All right. So in this, the key about this game is that if the statement is true, is valid in every, right, then you can, the prover has a strategy. And if the statement's false, then the adversary has a strategy. But so by looking at whether or not it has a strategy, we can see, right? So here, right? So this is just saying, oh, I've started introducing, when we get to formal proofs, we're going to be stripping away the foralls and the exists. And we need notation to understand what we have. All right? So here I'm kind of using this notation to say B is an arbitrary free variable. And then once you have B, you can plug it into some function that exists that's going to give you a girl that he loves, right? Does that make sense? Everybody follow this? All right, so here's another statement, right? And this is to emphasize that order really matters, right? If you switch the quantifiers, all right? So the difference between the game is who goes first, right? So in this game, we read left to right. Who goes first is the prover has to come up with a girl, right? And then the adversary gets to go and find a boy that doesn't love Marilyn Monroe, right? Does that make sense? So this statement is false. Anybody not following this? Right? Right? In order to win, how would you win this game? Right? There would have to be a one girl that, if everybody loved Marilyn Monroe, right? There has to be one girl. I could produce that one girl, and then no matter what the adversary does, right, I would win. Right? In this case, right? I produce Marilyn Monroe, and now the key is that the adversary knows that I've chosen Marilyn Monroe, right? And she has to, right? He produces an arbitrary boy, and then the prover has to prove that the arbitrary boy loves Marilyn Monroe, right? Right, and this one is slightly different. We're condensing it to this, right? Again, B is an arbitrary value, right? But before G was as a function, and now it's a fixed value, right? So we're saying there exists this fixed value that works for all boys. So it's good to learn this condensed notation, right? All right. Now people might argue, how can you prove a Forall from only one example? And so I guess the intuition is that if we trust the adversary to give us the worst case, right? And besides, we're saying the statement is false if, or the statement is false if the adversary has the strategy. We're not saying the adversary, we know the adversary's strategy, right? And similarly, it's true if the prover has a strategy, right? Right? If the prover has a strategy, right? I mean, we have to prove that we can always win, right? No matter what the guy does, right? All right. Right. So this is just saying, how do we define a? It's not like we're proving I can beat you, right? We're proving that I have a strategy in which I can beat anybody, right? So that's why we say B is arbitrary supplied by the, right? We don't know what the guy's going to give. And then, right, so here, I'm assuming B is coming as an arbitrary object, and then I have to come up with the girl, right? But since I know the boy already, which girl I come up with is a function of the boy, right? So instead, so really what I'm doing is I'm specifying a function of how, given a boy, how do I get my girl, right? Does that make sense? And in some ways, you can see right here, this is kind of a function, right? For every boy, right, we could define a girl, right? Right. So now the game, we play the game, but the adversary has a winning strategy, right? It's right. The adversary has to say, I get to come up with the boy. So in fact, if we're trying to prove this false, how do you prove a sentence false? Is you can either negate it and bring the negation in, which switches all the foralls that exist, right? Or you can give me a strategy in which the adversary wins, right? So here, what's the winning strategy for the adversary? The winning strategy is the adversary says, we'll let the boy be Sam, right? And then, and now if we're coming up with the strategy for the adversary, right? The adversary doesn't know what the prover is going to do, right? So the prover will say, let G be an arbitrary girl, right? We're just switching the roles, right? And then we prove it doesn't, right? And so that's the equivalent to taking the negation, right? If an adversary, a strategy for the adversary for this is the same as the strategy for the prover for this, right? People see that difference? Yeah. You guys are getting, that's what happens every term. People are enthusiastic the first month, and then they start to wane. We got one head shaker in here. Two, a little bit. All right. Right? So this is just saying if there's not a girl for which it's true, then for all girls it's not true, right? There's a test on Wednesday, and what we're doing today is on the test. All right. Though I must admit I had some hard Forall questions on it, and I started thinking, oh, maybe I should make the Forall questions a little easier. All right. Right, so this is just what I'm saying. We're just switching the roles. People, I don't know, I think we've said it a couple of times already. All right, so some people say maybe we should be in George's class because this isn't formal. We can't do this in a job interview, and I actually bet that if you were at a Google interview, you could do it just fine. All right. And on the other hand, if we were trying to prove something complex, like I in fact had this as a homework assignment for this course, you want to prove that if you have a planar graph where no edges cross, then you can color it with 6 colors, right? And if I was, if I were to get up here and put the proof on the board, we were just talking about he's taking calculus, and people put epsilon delta proofs on the board. And my bet is that most of the class has no idea why we're doing, when do we say X is arbitrary? When do we construct the X? What order do we do things, right? Most people have no idea what we're doing. And what's crazy is, I took calculus. They teach you epsilon delta proofs. They put down for all epsilon there exists the delta, but they never really teach you how to prove these things, right? And if And knowing this game and knowing that we're going left to right will help you knowing how to do all these proofs, right? Right? Everybody good with that? Right? So if I was writing it on the board here, I wouldn't do nobody. I bet you even George, if he was proving this statement, would use his proof system. Right? They would say, hey, let X be an arbitrary object, right? They would say how do you construct an object, right? Or if you have an oracle, if you know something is true, then you say, well, let X be the object that we know exists, right? Everybody good with this? All right.